Okay, so here's the answer to the gold prospector problem. If you had this function, and you found the vertex, which is the way we find the vertex when it's in standard form, is x equals negative b over 2a, we can come up with the idea that x is going to be 250. So if the height, if x is 250, and we put it into this equation, our vertex is 250, comma, do all the math, and you get 62,500. So what does this actually mean when it comes to the gold prospecting problem? Well, if the height of the rectangle is 250 yards, then the area will be maximized at 62,500 square yards. That's a pretty big space of land. Now, in this particular case, the gold prospecting problem, the base is also going to be 250 yards. So something that we talked about in class is that the maximum area of any rectangle is always going to be the square. However, that is only if you're using the entire perimeter as your enclosure. When it comes to the llama problem, this is why this is going to be a little different. If we're using the stone wall as a part of our enclosure, we have a perimeter that is 150 yards, but remember, we're only using 3 sides because we have one side that's already existing. So our fencing is only going to be 3 sides. If our fencing is 3 sides, our perimeter is twice h plus b, and that's our perimeter. So once I know that, I can solve for one of my variables, and I'm just going to solve for b, because if I solve for b, I have integers. If I solve for h, I'm going to have to deal with fractions. So going back to what we did with the gold prospecting problem, we still have to set up our area. Our area of this particular rectangle is b times h. Well, instead of writing b, I'm going to substitute b in for 150 minus 2h. So if I substitute that in, instead of writing this letter b, I'm going to write 150 minus 2h times h equals a. So when I simplify this guy, I get 150h minus 2h squared. And like I said, you might want to look at this as an x and a y, and you're okay to do that, but before you do that, you have to sketch your graph. You know that distance is only positive, so we're only going to use the first quadrant. We know that our a is -1, not the a as the area, but the a as the coefficient on the quadratic term. So that means our parabola is going to be facing down. So we have a downward facing parabola. What is the x value? What is the x-axis? Well, the x-axis happens to be the height. And what is the y value? The y value happens to be the area. So now that I have all this done, I'm going to rewrite this to make it easier for myself as a function. Y equals 150x minus 2x squared. If you don't have to do this next step, that's okay. But if you do, then that's okay too. So again, I'm going to go through and find the vertex. The vertex is x equals negative b over 2a. So that comes out to be negative 150 over 2 times negative 2, which equals negative 150 over negative 4, which equals positive 37.5. Now if x equals 37.5, I want to put that on my graph, and then I'm going to go in, take this 37.5 in my calculator, and put it into my calculator. So I have 150 times 37.5 minus 2 times 37.5 squared, don't forget my middle name, equals. And so the y is going to equal 2,812.5. Well, what does that actually mean? This is 2,812.5. So what is the y again? The y is the area. And what is the x? The x is the height. So this point, 37.5, comma, 2,812.5, this represents the height and the maximum area. So when we have the maximum area for our llama pen, we're going to have a maximum area. We're going to have a maximum area of 2,812.5 square yards. That's a pretty big space. Now, what does that mean? Well, that means that the height, the h, we're going to go way back to our drawing. That's why we draw. We go way back to our drawing. So if our h equals 37.5, what is our b going to be? Well, we have to plug it in because we know what our b is going to be. b is 150 minus twice h, 37.5. So again, I do that on my calculator, or do I really have to? I don't really have to, but I can. So 150 minus 75 equals 75. So if I go back, that's all the math. I just was doing the math. That's what you missed. So if I go back, the dimensions of my pen are going to be 37.5 yards by 75 yards. And that's going to maximize my area. So this is why we can't just say, well, the square is always the maximum area, because this indeed is not a square. What if we had 150 yards of fencing and we made it into a square using the stone wall? If we made it into a square using the stone wall, this is what it would look like. Here's the stone wall. If we made this into a square and the perimeter was 150, each side would be 50. Would you agree? Oops. And what's the area of this square? The area of this square is 25 with 2 zeros. Is that bigger than 2812.5? It's not. And that's why we learn how to do this with quadratic functions. So I'm going to put this back. Okay, and I'll bring it all the way up so you can see all of the work. Oops, a little bit more. So you can see all the work involved in the llama problem. And pause it if you'd like and check that out. Have a great weekend.